To use GDB, you have to add -G after GCC. Let's consider a simple example. In this program, we have three variables, A, B, and C. They are assigned values -9, 4, and 6. Remember to add -G when you compile the program. You should always turn on the warning messages. To debug the program, simply type GDB, the name of the program. We can use the command list to show the source code. We can create a breakpoint at the main function. The command R means to execute the program. We can print the variable A. As you can see, A's value is garbage. That means the breakpoint stops before executing this line. Now A has been initialized to -9. B's value is currently garbage. If we type N again, B's value is initialized to 4. We can type N again and go to the next line. The command display will print the value of A every time we type N. As you can see, the value of A is printed, even though we did not say print A. Finally, C will continue the program and the program stops. This is a review of the commands we have seen so far. We can set a breakpoint at a specific line. In this case, the breakpoint is set at line 6. When we execute the program will stop at line 6. As we can see, A and B have been initialized to -9 and 4. We can also use the command info B to provide information about existing breakpoints. Currently, we have one breakpoint at line 6. This shows the new commands. Now let's consider a new program. This program has a loop. The variable A will start from 0 and go up to 99. We'll add A's value to B. When we debug this program, we can set the breakpoint at the main function. The value of B is initialized to 0. We can use N to trace this program. We display A and B so that their values will be shown. We don't have to type print so many times. As we can see, the variable A will be changed inside this loop. There is another way to create a breakpoint. In this case, we want to stop at line 8 only if the variable A is larger than 73. As you can see, if we type info B, it shows two breakpoints at line 5 and 8. If we type C to continue, the program will continue until the value of A is larger than 73. It shows the value of A is 74 now. If we continue, it will stop again because 75 is larger than 73. We can disable the breakpoint. It shows currently the breakpoint is not enabled. If we continue, the program will run to completion. Next, we consider a program contains two files. The first file contains two functions, G1 and G2. G2 calls G1. The main function will call G2 twice. The purpose of this demonstration is to show that GDB can handle programs with multiple files. If we execute this program, it will print the value of the argument x in different places. Let's start GDB. We can set a breakpoint at the main function. We can also set a breakpoint at function g1. We can also set a breakpoint at a specific line in a particular file. As you can see, GDB knows which file to use. Notice that we can specify the line number of a file. Execute a program, GDB will stop at the main function because there is a breakpoint. Use the next command to go to the next line. In the main function, the value of x is 5. The x command allows us to enter the function. Currently, we are at function g2. The value of the argument x is 13. Use the next command to go to the next line. We are still at the function g2. Use the x command to go to function g1. The value of the argument x is 3. The bt command means backtrack. This command tells us the function calls. Currently, we are at function g1. g1 is called by function g2. g2 is called by function main. bt command also tells us the value of the arguments. In g1, x is 3. In g2, x is 13. The command f allows us to go to the coder. g1 is called by g2. Command f1 will go to g2. Inside g2, the value of x is 13. g2 is called by main. f2 goes to the main function. Inside the main function, the value of x is 5. As we can see, the value of x depends on where we are. In g1, x is 3. In g2, x is 13. In main, x is 5. Info B tells us there are 3 breakpoints right now. Use F0 to go back to function G1. Let's go to the next line. Since x is larger than 0, G1 returns 5. In G2, the value of y is 5. G2 returns y, y's value is 5. In the main function, y's value is minus 7. Main function calls G2, the argument is minus 7. G2 calls function G1. The value of the argument is minus 17. Again, we can use the bt command to show the function calls. We are currently at function G1. G1 is called by G2. G2 is called by main. The purpose of this demonstration is to show that GDB can handle programs with multiple files. GDB can also allow us to go to different functions and see the values inside different functions. Finally, the program will print the values of A and B. They are 5 and minus 11. This summarizes the new commands we just introduced. If you want to learn more about GDB, you can go to the GDB's website. Click Documentation.